Hi there and welcome to our C1 carbon chemistry topic, and today we're looking at our first lesson on fractional distillation. So if you have any problems with the homework, you can contact me here, or that way there. You can email me or contact me on Twitter. Anyway, I will see you at the end of the lesson. Bye bye. Okay, so let's have a look at our objectives for today's lesson. So our lesson on fractional distillation is, by the end of this lesson you should know and understand how fossil fuels are made and where they come from, and how hydrocarbon fuels in crude oil can be separated for use. You've probably heard of the term fossil fuel, but we're going to look today at what fossil fuels are. There are three types of fossil fuel. These are coal, crude oil and natural gas. Coal obviously has the appearance of a black solid, whereas crude oil has the appearance of a black liquid, which you can see from this picture here. Whereas natural gas has a invisible appearance, but you can obviously burn it with this nice blue flame here. Now that links us nicely to what we use fossil fuels for. Now fossil fuels are obviously used for burning, but they are in fact what we call a finite resource, which means they're going to run out. This is because they are non-renewable. Now it's becoming more and more difficult to extract these. I mean, coal we have quite a big supply of left, but oil and natural gas have a very, very limited supply left, and we're actually searching for very, very remote parts of the world to see if we can find any of this crude oil. Now, as we've seen from this picture here, crude oil can actually be leaked into the surface of the earth from where it's from originally, which is the Earth's crust. Now you can see here that the crude oil is in fact a very thick, black, sticky liquid. Now when we extract this, we need to transport it, and there are two ways we can do this. The first, that you're probably familiar with, is via an oil tanker such as this one. So there will be stored in here lots and lots of crude oil. The other one is via oil pipeline, and you can see here that this pipe is travelling for miles and miles and miles, and it is transporting the oil. Now what it does is it transports the oil from the oil field, which is under the Earth's or in the Earth's crust, and it takes it to an oil refinery. Such as this one here. Now at the oil refinery we can actually go through the separating process, and we can actually get the crude oil, which is that black, sticky, thick liquid, and we can make it into more useful products. Now separating crude oil is extremely important. The crude oil itself, the black liquid, is absolutely worthless on its own. However, when we get the individual parts or the fractions of the oil, then we can actually get some really quite useful chemicals. Now everything in the crude oil is something called a hydrocarbon. Now a hydrocarbon contains two elements, which are really quite simple to guess what they are. It is hydrogen and carbon. Now these can be separated by heating them in what we call a fractional distillation column. Now this is what a real life fractional distillation column looks like, and you can see here we've got different levels and at the bottom we have the crude oil that's pumped in, and then you might be able to see on the side here definitely is pipes that take it away. Now if we look at a diagram of how this actually works, here we can look at the crude oil coming in is heated. Now it's heated to turn it into a vapour. Now the vapour enters the fractionating column, and some of it will condense immediately into a liquid, and that can be taken off here. Now this tends to be the bigger molecules, so the bigger molecules come to the bottom. Now you might be able to read here, this is something called bitumen, and that's used as the sticky stuff to hold the tar onto the road. Now as we go up, we have things starting to condense. So here we have fuel oils, which can be used for heating power stations or for powering boats as well. As we go up, we get a slightly lower boiling point, and this is where we get lubricating oils, which is the oil that you put into the engines of cars. Going further up here, we get diesel, which is used to power lorries and vans and so on. We then have other fuels such as paraffin and heating oils. This includes things like naphtha and kerosene, which is used for fuels for aeroplanes. Then as we get closer to the top, we then have petrol, which is obviously used for powering cars, and then we have LPG, which is liquefied petroleum gas, and this is things like butane, propane that you can find in these gas canisters here. Now you can see this diagram here, it shows quite a big molecule, and this is a smaller molecule. Now as well as going up the column, we get a lower boiling point, so all of these will remain as gases. These will all start to condense as liquids as they move further at the top. Now as you go further up the top, the molecules start to get smaller. Hydrocarbons have a very simple pattern to follow. Now if we draw a simple hydrocarbon here, we can see that it does only have hydrogen and carbon atoms in, with each letter representing carbon, carbon, hydrogens going around the outside. Now this is a very small hydrocarbon because it's only got 2 carbons, and they can go all the way up to about carbon 50. Now as we get longer chains, so I'm just going to show you, if we draw our chains like this, with each point being a carbon atom, we can have short chains like this, or we can have very long chains, okay, as we said, going up to 50 carbons long. Now if we had 2 short chains side by side, they actually have a force of attraction. So this is one molecule, this is a second molecule, and they have forces of attraction between them. Now this is called intermolecular force. So they have a force that's between the molecules. So intermolecular force means force between the molecules. Now if we were to draw a slightly longer one, we can see the forces here. There would be more forces because it's longer, so there would be more forces holding them together. And then if we had a look at an even bigger one here at the bottom, you've guessed it, there would be even more intermolecular forces between them. Now the more intermolecular forces there are, the higher the boiling point will be. So for example, this, which is butane, might have a boiling point of around about minus 10 degrees. Now this one here, which is perhaps pentane, might have a boiling point of about 40 degrees, and then this one here, which is a lot longer, may have a boiling point of about 100 degrees. So the bigger the molecule, the higher the boiling point will be. Okay, so let's just sum up what we have covered during today's lesson. We have looked at 3 different fossil fuels. We've looked at coal, crude oil and natural gas, which all of them are found in the crust of the earth, and they are all made from dead plants and animals. We've then looked at transporting them via pipeline or oil tanker, and then we've looked at separating just crude oil. And we've looked at how that is separated by heating it, and then looking at the boiling points of the different molecules to see when they will boil, or oppositely they will condense to form liquids, and then we can remove them from a fractional distillation column. Now there is also a pattern that the longer the molecule, the higher the boiling point will be. So if we go back to our fractionating column here, let's pull that up here, the long ones at the bottom will have a very long chain, and these ones at the top will have a very short chain. Anyway, I hope you have enjoyed this lesson and got a lot from it, and I will see you next time. Bye bye.